All right, so continuing on to chapter 8, 8.1, right triangle trig applications. I'm going to write down things that you should already know, but just in case, when we have sine of a specific angle, we use opposites over hypotenuse. When we use cosine of a specific angle, it's adjacent over hypotenuse. When we use tangent of a specific angle, that one is opposite over adjacent. Same way, cosecant, which is the inverse of that one, it would be the other way around. Hypotenuse over the opposite side. Secant would be hypotenuse over adjacent. And your cotangent would be adjacent over opposite. So you remember when you were in elementary, they would say SOHCAHTOA? Or no?
I think it was more like
Is it, what did I say?
elementary.
Elementary, yes, sorry. In high school, they would tell you SOHCAHTOA. So it's SOH, what happened there? Tell me. What in the world? There it is. Beautiful. Okay. So it is SOHCAHTOA because it's HOHCAH and TOA. My goodness, the focus of this is just so beautiful. Look at that. All right, there it is. So that's something that we need for today's lesson, along with other stuff. So if this is your angle and this is your 90-degree angle, this is considered who over here? This is your opposite. This is your hypotenuse. And this is your adjacent. So we need to remember, according to where the angle is at, which one's your opposite, which one's your hypotenuse, and which one's the other one. So for the first example, which are not the first problems on your assignment, but you should be able to do them. Example number 1, use a triangle. Not just a triangle, but the right triangle. And given information, to figure out the missing stuff. Figure out the missing length and angles. Now, how many degrees is there in a triangle? 180. Please tell me you're joking. Okay, so if they tell you B is 5, B is 20 degrees, and they want you to find little a, little c, and big A. So anytime they use the lowercase is always going to be for the sides. The uppercase is always going to be for the angles. My recommendation to you is for you to actually draw a triangle, because that's the only way you're not going to make a mistake. This is my 90-degree angle right there. I'm going to call this C, and this is your A, and this is your B. We have A, B, C. They already tell you your B is what? 20 degrees. And they tell you that little b, and little b is always going to be where from the angle?
Side,
Across. It's going to be across. So this is little b, this is little a, and this is little c. So your sides are always the opposite side of your angle. So if I know that this is 20, this is 90, can I already figure out what my angle A is? It is 70. How do you know? Because 90 plus 20, subtract that from 180. So A equals 180 minus the 20 minus the 90, which is the 70 degrees. This is angle A. So I already found out that part, and you can go ahead and write it in there. This is 70 degrees in case you need to see it. Using the formulas from up here, you have a choice of what you could use. But if we use the 20 that they give us at the beginning, and I need to find little a and little c, from this 20, this is what to it? The 5 is opposite, adjacent, or hypotenuse? Opposite. And the little a is what? Adjacent. So if I'm using opposite and adjacent, which one would I use? Sine, cosine, or tangent? Tangent. So I have tangent of 20 degrees equals my opposite, which is 5, over my adjacent, which is 8. Now, how do you solve for an angle when you have something like this? I'm going to put this little guy over 1, and then you cross multiply. So I have 5 equals a tangent of 20 degrees. So if I'm trying to solve for a, what do I need to do with that 20 degrees? Divide. Now, I'm hoping you have a calculator, and I'm hoping you have it in degrees, because if you don't have it in degrees, the answer is going to be wrong. So a equals 5 over tangent of 20. Plug that into your calculator. 5 over tangent of 20. And for the sides, we're going to do 2 decimals, and for angles, we're always going to do 1. So what is 5 divided by tangent of 20? 13.74 is correct. So this is your A. So I found A, I found angle A, but I'm still missing what side? C. So I'm missing this guy, and this is a hypotenuse. Now, would you rather use the 5 or the 13.74? The 5. So from angle B, this is opposite, and this is your hypotenuse. So who uses opposite and hypotenuse? Sine. So now I'm going to do sine of 20 degrees equals opposite, which is 5, over the C. And you do the same thing. 5 equals C sine of 20. Divide by sine of 20 degrees. So C equals 5 divided by sine of 20. And that right there gives me 14.62 is correct. So did I find A? Yes. Did I find little c? Yes. Did I find angle A? Yes. So you are done. Are we okay? So this to me is a lot easier than having to use all those identities. That's just me. All right. Can I turn the page? Yes? Okay, let's do another one. They tell you A is 2, B is 5. Can you please find little b, big A, and big B? So I'm going to draw a triangle. A, B, C. C is going to be A. Little b, oh, because this was supposed to be c. My bad. Thank you. So this is supposed to give you a and c. My bad. Thank you, ma'am. So that's little a, opposite of angle A. This is little b, opposite of angle B. This is little c, opposite of angle C, which is 90 degrees. C is 5. So this is 5. Little a is 2. And they want you to find little b, angle A, and angle B. So who's the first thing you could actually find with the information that they give you?
The Pythagorean theorem.
So we could find C using Pythagorean theorem. Excellent. So I have C squared equals A squared plus B squared. C squared is 5. A squared is 2 plus B squared. That's 25. And of course, what do I have to do with that 4? Subtract it. So what is 25 minus 4? 21. And what is the square root of 21? Because we actually need an actual answer for this one. I find out that B is 2 decimal places. 4.58 is correct. So I found B. There it is. Now, how do I find my angle A?
The
And B.
inverse. Right.
The who?
The inverse.
The inverse. Very good. So we set this up, first of all, sine of A, because I need to find angle A. Sine, because I have opposite over hypotenuse. Sine is 2 over 5. But anytime that you look for the angle, it is the inverse of that opposite over hypotenuse. So what is the inverse of 2 over 5? And for degrees, we're doing 1 decimal place. So angle A will be 23.6 degrees. That is correct. And once you find this 23.6 and you know that angle C is 90, how do you find B?
You can do 90 plus that minus 180.
Or the 180 minus 90 minus the 23.6 tells me that B is 66.4. So when they only give you sides, the right approach is to start out with Pythagorean theorem and work from there. So you guys are good with these problems? Pretty simple? This does look like high school geometry, these parts here, at least. Let's look at C. The hypotenuse of a right triangle is 5 inches if one leg is 2 inches. Find the degree of each angle. So they give it to you in a word problem. We draw a triangle. This is A, this is B, this is C. Little a, little b, little c, and they tell you the hypotenuse is 5. So which is the hypotenuse, A, B, or C? So this is 5, and then they give you a leg, and the leg is what? 2. And then this turns out to be exactly which problem? The one above, but they gave it to you in a word problem. So the only thing they're looking for is the measure of each angle. So here are my 2 answers. I had not noticed that until right now. So A is 23.6, B was 66.4, and if they ask for C, that one is the 90 degrees. I think it's time to take away. Let me give you another word problem. And I'm thinking that one is different. For D, so the only reason we didn't do any work was because it was exactly the same numbers as the previous problem. Just let it be. A right triangle has a hypotenuse of 8 inches if one angle is 35 degrees. Find the length of each leg. Find the length of each leg. So let me draw a triangle so I can understand what's going on. A, B, C, A, B, C. So it says a right triangle has a hypotenuse of 8. So this is 8. One angle is 35. So I'm going to just call this one 35. It could be A or B. I'm just going to let it be A. So it says to find the other legs. So how do I do that? What would you use?
You can use the A angle and then the hypotenuse formula.
Okay, but so if I use A, and I use A and the hypotenuse, and I would use which one? Sine or cosine? Sine. Sine of 35 equals opposite, which is A, over hypotenuse, which is 8. Put this over 1, you cross multiply for this one, it gets easy because it's just A equals 8 sine of 35. So I don't have to divide by anything. What is A? 4.59. Now, I can use this 35, but if I want to look for B, because it says find each of the legs, I have to not use sine, but use what? Cosine of 35 equals adjacent, which is the B, over the hypotenuse, which is 8. B equals 8 cosine of 35. So B is
6.7.
55. You got 6.55. Are we okay? All right. E, you have a Eiffel Tower that looks nothing like the Eiffel Tower. I know, it's so sad. You are 80 feet from the Eiffel Tower. This is an angle of 85.361 degrees. This angle is 85.361 degrees. And you want to know what is the height of the tower. So am I looking for the opposite or the hypotenuse? The opposite, because you're looking for the height from here to here. So from this angle, because that's the number I have to use, I'm looking for the opposite, and this is my adjacent, so I have to use which trig function? Tangent. Very good. Tangent of 85.361 equals opposite, which I don't know, so I'm just going to let that be x, over my adjacent side, which is 80. So x equals 80 tangent of 85.361. So x equals how many feet? Very good. 895.81 feet. Angle of elevation and angle of depression. When you are standing here and they want you to look for an angle of elevation, your object has to be here. You're looking up at it. So this one here is your angle of elevation. And here's your 90-degree angle. When you are standing here and you are looking and your object is down here, this here is called the angle of depression because you're looking down. So depending, and I think all the word problems that I saw dealt with elevation, but just in case they told you depression also, then that would be the situation. Example number 2, the angle of elevation of, sorry, I'm just reading this. And they tell you it's an angle of elevation of the sun is 35.1 degrees at the instant that the shadow casted by the Washington Monument is 789 feet. Calculate the height of the monument. So you have the monument here. It casts a shadow of what? 789. Because they use angle of elevation, this is your angle of elevation. And that right there is 35.1. And you're looking for x, which is the height of the monument. So I have to use which function? Tangent. Tangent of 35.1 equals opposite over the 789. So x equals 789 tangent of 35.1, which is 52 feet. That is the height of the building. All right. We're going to do an example 3, and that's the last one. When you hear the word complementary, how many degrees is complement? Complement? 90, right? Okay. So in this section is a little odd, but this is the way they do the work. So for example, number 3, and these are going to be the first problems on your assignment. They're going to say, can you please find the exact values of the expression? Now, something you need to kind of understand, and let me write this first. Complementary angle theorem. They're telling you that sine of 30 degrees is the same thing as cosine of 60 degrees. Does that make sense, or do I need to draw a picture so you understand why? Yes or no? 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 It makes sense? Yay or nay? If this is my angle and this is 30, this has to be what? 60. So this is why this is sine, but it's the same thing as doing the cosine, because you would find the same thing. And that's really the only one you need for today's deck. Yep, because that's the only one they talk about. They also give the example of tangent of 40 is cotangent of 50. And secant of 80. So these are the little examples that they suggest, just so you kind of. So sine and cosine, tangent, cotangent, secant, and cosecant. Now,
put those numbers there
and where?
in the triangle.
Why?
Not asking.
Do you? You don't have to.
Like, did you just?
Oh, I just did this one.
But you just put it in there for like no reason.
Like they're trying to say, if I were to do sine of 30, is the same thing as calculating for a cosine of 60. They're exactly the same thing. They're equal to each other.
Oh,
Just forget about the triangle. Sorry, my bad. So they're going to give you a problem that looks like this. 1 minus cosine squared of 20 degrees minus cosine squared of 70 degrees. What can I do with this so I could simplify and maybe actually calculate an answer? So what they do here is this 70 I could get from subtracting 90 and 70, which gives me what? 20. So this cosine squared of 70 is the same thing as having sine squared of 20 degrees. I don't know why I put so many parentheses. Now, we have learned from the Pythagorean theorem that, well, first of all, what do these two things have in common? They both have what in front?
minus.
A minus, right? So can you factor out the minus? So this becomes negative cosine of 20 plus sine of 20. If these things are an addition and they're both the same, it actually becomes a what? What is cosine squared plus sine squared? 1. So this becomes 1 minus 1, which is 0. So in the first few problems, you're going to end up using the Pythagorean theorem. The tangent is sine over cosine or cosine over sine, and all that crazy, wonderful, beautiful things. Now for B, tangent of 20 degrees minus cosine of 70 degrees over cosine of 20 degrees. Now, which degree do they use twice? The 20. So is there any way I could change the 70 to a 20? If I change this to a sine of what? 20. So this is tangent of 20 minus, and in case you're wondering where that 20 is coming from, 90 minus 20 minus the 70, sorry. So we have tangent of 20 minus sine of 20 over cosine of 20. But what is sine of 20 over cosine of 20? Tangent of 20. And what is tangent of 20 minus tangent of 20? My answer is 0. Does it make sense? Sort of, kind of, not really.
Yeah.
And one last one to finish this whole section. Cosine of 35, sine of 55, plus sine of 35, cosine of 55. So let's use the smaller angle, which is a 35. Is 90 minus 55 35? Yeah. So this here is cosine of 35. This becomes cosine of 90 minus 55. This is sine of 35, and this here becomes sine of 90 minus 55. So everything is going to become a 35. This is cosine of 35, cosine of 35, plus sine of 35, sine of 35. And what do you think happens there? They combine, they become what? Squared, right? Cosine squared of 35 degrees plus sine squared of 35 degrees, and this equals 1, and you're done. So this here is your 8.1.